All right, so for the idea of bivariate data, guys, it's the concept of how you are comparing two quantitative items, or qualitative items to each other. So a comparison of different groupings, and that they don't necessarily follow a linear pattern. So it could be a scatter plot that is showing kind of a linear relationship, but doesn't necessarily go in a line, but you could plot what we call a line of best fit. It might have some curvature to it, so that you won't be able to plot a line of best fit. And it just shows how there's associations to each other, positive and negative, or no associations whatsoever. We're going to begin first with some two-way tables where it's describing different groups that have the possibility of an overlap or no overlap. You guys probably tend to see them in Venn diagrams, especially in like social studies, where you have two circles or maybe three circles, and you've got a section here. Let me draw it off to the side, where you've got maybe one section off to the side that covers one group, and then you've got another section that represents another group, so group A and group B. And then what is this portion is where group A and group B happen to overlap. It's a similar process of what we're doing with the two-way tables. They're charted where you've got group A and group B, those who belong to group A, those who belong to group B, those who do not belong to group A, do not belong to group B, and those who belong to both or belong to neither. So it's just showcasing it here. So in this example that I've given you a situation of bilingual students. So students who speak Spanish, students who speak English, students who speak both, or students who speak neither, okay? And the way that it's displayed here, so for this very first value that we see, this 30, this represents 30 students who speak English as well as speaking Spanish. Okay, if I go off to the right, this 65 represents people who only speak English. They don't speak Spanish. And then when you calculate those together, this 95 represents the total amount of English speakers. So you're following your rows and columns to see what they line up with. Same thing for here. This 50 represents the total of Spanish speakers. Here, this 120 represents the total amount of people who were surveyed for the entire process. So 120 people who represent the entire group. Okay? So what we're going to do is, based off of the information that we're seeing here, I want to identify whether the following statements are true or false. So for problem number 1, it says the majority of students do not or don't speak Spanish. The majority of students do not speak Spanish. So what we're going to be doing is we're going to take a look at how many people speak Spanish versus how many people do not speak Spanish. How many people speak Spanish? 50. We have 50 people here who do speak Spanish, right? Spanish speakers, total amount of Spanish speakers represented by the 50. How many people do not speak Spanish? 70. Okay, so we are looking at those who do not speak Spanish as 70 versus those who do speak Spanish as 50 out of the 120. Okay, so is this a true statement? Out of the 120, do majority or most of them not speak Spanish? That's true. That is true. Again, we're looking at who does not speak the Spanish. That would be this value right here, 70 people. 70 people. So this is a true statement. This is a true statement. Because out of the 120 students that we have a total of 120 of them, 70 of them do not speak Spanish. That is more than half. Okay, if it's more than half, that's considered to be a majority. Ew. All right, problem number 2. There are more Spanish speakers than there are English speakers. There are more Spanish speakers than there are English speakers. So, how many people speak Spanish? 50. 50 people. So we're looking at Spanish and we're going down to the total. 50 people speak Spanish. How many people speak English? 95. If we look at English and go all the way to its total, that would be the 95. So now that says that there are more Spanish speakers than there are English speakers. Is Spanish bigger than English? No. So this would be a false statement based off of what we see here. Okay, this is false. Okay, because there are 95 English, which is greater than the 50 Spanish. Okay, I want you to try problem 3 on your own. Identify whether that is a true or false statement. The majority of English speakers do not speak Spanish. Identify if that's true or false. All right, the majority of English speakers do not speak Spanish. Is that true or false? True. It's true. Okay, if we take a look, so we're focusing on just the English speakers. So we're comparing English speakers that do speak Spanish, which was 30, to English speakers that do not speak Spanish, which is 65. They're saying that we're going to have more speakers that don't speak Spanish, more English speakers that do not speak Spanish than we do those who do speak Spanish. That is a true statement. Okay, this is true because we have 65 English, not Spanish, which is greater than the 30 English Spanish. Okay, 65 English speakers that do not speak Spanish compared to the 30 English speakers that do speak Spanish. Okay, now, relative frequency. When we're talking about relative frequency, what we're doing is we are setting it up as a fraction, converting it to a decimal. You can convert it to a percent. It's kind of like setting it up for probability, where you're comparing two values. So instead of it being out of a total, it's a comparison of one group to another. So sometimes it might be out of a total, but not always. Okay, so for here, they're saying that the relative frequency of Spanish English speakers to Spanish is greater than the relative frequency of non-Spanish English speakers to non-Spanish speakers. Okay, so you're setting it up for two different kinds of frequencies that we're going to focus on. Let's first focus on our Spanish English speakers to our Spanish. Okay, Spanish English speakers. Spanish and English is going to be that 30. Spanish and English speakers compared to just our Spanish speakers. Just our Spanish speakers is going to be that 50. That's the Spanish total. Okay, so we're comparing the 30 to the 50. We're going to set it up as a fraction. So this would be our Spanish English speakers over our Spanish total. So our Spanish English speakers was 30 over our total, which was 50. Of course, you always want to simplify your fractions. That can simplify to 3 over 5. And then you want to convert it. You can convert it by dividing. You can take 3 and divide it by 5, and that's going to come out to 0.6. So you can have it in fraction form. You can have it in decimal form. Or you can even put it in percent form, which means you take that 0.6 and multiply it by 100, and that comes out to 60%. Okay, it's always good to have it in all three formats for comparison. It's probably easiest to do a comparison when it's in percent form, though. Okay, and then we're going to do the exact same thing again, but we're going to do it with the other frequency. That's the non-Spanish English speakers compared to the non-Spanish speakers. Non-Spanish, but speaks English, compared to just non-Spanish total. So we're going to look up here. Non-Spanish, but speaks English. How many people do not speak Spanish, but they speak English? 65. And then how many non-Spanish speakers in total are there? 70. So you're comparing those two values to each other, 65 over the 70. So we're going to do non-Spanish, no Spanish, but they speak English, so that's NS, but they speak the English, over no Spanish total. Okay, I'm just trying to abbreviate. It makes it easier to write. So we've got 65 out of 70. Of course, we always want to simplify it. When we simplify it, that comes out to 13 over 14. And then you want to go ahead and convert. So we're going to do 13 divided by 14. It's always best to just go ahead and round it to the nearest tenth. That's going to come out to approximately 0.93. And then we want to convert it to a percentage. So we would take that 0.93 and multiply it by 100. That gives us 93%. Okay, so we've got a decimal, we've got a fraction, we've got a percent. Now, they're saying that the first frequency that we talked about is greater than the second frequency. Is 60% greater than 93%? No. This is going to be a false statement. This is false. 60% is not greater than the 93%. Okay, so this is a false statement. So that's how you utilize a frequency table, or sorry, a two-way table to identify frequencies, to make comparisons. That's basically what you're going to be doing. You are going to be looking at frequency tables and identifying if statements are true, are they false, or what is the frequency when you're comparing. You also will have to fill in frequency tables. So given a statement or a paragraph of information, you are going to create the frequency table. So go ahead and flip it on over to the back. So taking a look here, at the very top, there are 150 kids that are attending a summer camp. 71 of those kids signed up for swim. There's a total of 62 kids that signed up for canoeing, and 28 of them also signed up for swim. So we want to take this information and we want to fill that stuff out. So we're going to start with the very first number we see. 150 students that are at the camp. Where does that belong on this table? Alex? The very bottom right corner, the total. That's what we'll call it, total. Or here, go ahead and let me just number these. In the top left-hand corner of each of them, let's just go ahead and number this 1, 2, 3, and then we'll go down 4, 5, 6, and then the bottom row, 7, 8, and 9. So you're saying it's going to belong in box 9, 150. Okay, that represents all the kids that are at camp, whether they do canoeing or swim or neither or both. That's the total number of kids that are at the camp, right? Let's go to the next number. This next number that we're seeing, it says 71 signed up for swim. 71 of them signed up for swim. What box am I going to fill the 71 up with? Trang? Box 3. Good. So we have swim, and it's their total. So 71 is going to belong to box 3. Okay? The next piece of information. There are a total of 62 kids that signed up for canoeing. 62 kids that signed up for canoeing. Which box is that going to belong to? Yochan? 7. Okay, so we've got canoeing, and it's their total. So we're going to put 62 here. And then we've got our last one. Our last one says 28 of them are also signed up for swim. So where is that 28 going to go? Alex? Box 1. Because we're talking about the canoers that also signed up for swim. So there's 28 people who signed up for canoeing that also signed up for swim. So that's going to go in box 1. Okay, and that's all the information they've given to us. We can fill in the rest through deductive reasoning. How do I figure out the value for box 2, those who swim but do not canoe? What do I need to do, Armando? Very good. We have a total of swimmers. All we're going to do is subtract the 28 from it, and that's who's left for swimming but not canoeing. We're going to take 71 and we're going to subtract 28. That's what we're doing for that piece of information, and that gives us 43. Okay? What about for box 4? How do I figure out box 4? Bridget? Very good. We're going to do 62 and subtract the 28. Because we have 62 total canoers, 28 of those canoers are swimmers, so the rest are not swimmers. So 62 minus the 28 comes out to 34. Okay? Now, we can't fill in box 5 yet, but we can do box 6. What is box 6 going to do? Yoshan? 150 minus the 71. Good. Take the total number of campers and subtract the total number of swimmers, and you'll have the total number of non-swimmers there. Okay, so 150 minus the 71, and that's going to come out to 79. Okay, you can now do box 5, but we'll save box 5 for the end. Let's go ahead and do box 8. Box 8, we could do same process, do that 150, subtract the 62. We could do 150, subtract the 62, and that's going to give us 88. And the reason why I'm saying, hey, save that middle box for the end is because you'll know that you've done everything correctly if you could do 79 minus 34, and it comes out to the exact same thing as 88 minus the 43, which it does. Both values come out to 45. 43 plus 45 is 88. 34 plus 45 is 79. You've done everything correct. Okay? Now, based off of that, what I want you guys to do is you are going to find the relative frequencies for problems 1, 2, and 3. Relative frequencies based off of what they're indicating. Okay, let's go ahead and go over the relative frequency. So the very first one, it says they're focusing on the relative frequency of canoers to swimmers. So we want to focus on how many people canoe. So how many canoers are there? 62. So there's 62 people who were canoers. How many swimmers were there? 71. Okay, so we're putting 62 over the 71. When we convert that, that comes out to approximately 0.87, which is approximately 87%. Okay, so there's our relative frequencies. You could have left it as a fraction, a decimal, or a percent. Okay, for problem 2, the relative frequency of swimmers, canoers. So it's people who swim and canoe compared to people who do not swim and do not canoe. So how many people swim and canoe? 28. Okay, so swim and canoe, that's going to be 28 people. 28 that swim and canoe, compared to those who do not swim and do not canoe. How many do not swim and do not canoe? 45. There are 45 people who do not swim and do not canoe. Okay, so no swim, no canoe. Okay, so 28 over the 45, that comes out to approximately 0.62, which is 62%. Okay? All right. What is the relative frequency of not swimming to not canoeing? So no swim whatsoever, no canoeing whatsoever. So no swimmers. How many people did not swim at all? How many people did not swim at all? Not swim at all. 79. Not swim, 34. That represents they did not swim, but they canoed. This one is just not swim at all. So these people did not swim. These people also did not swim. So you have a total of 79 people who did not swim. So not swimming at all is 79. How many people did not canoe at all? 88, right? Here's not canoeing. 43 didn't canoe. Another 45 did not canoe. That's a total of 88 people who did not canoe. Okay, so you have 79 over the 88. That's approximately 0.9, which is 90%. Okay? Any questions on how to identify the relative frequency? Okay, so what I want you guys to do now is for this last problem, I want you to just fill in the table. You're going to fill in the table of information based off of what they've given us. And then find the missing information. Okay, let's go ahead and take a look at this information. I'm going to fill these in. This is box 1, 2, 3. Then we've got 4, 5, and 6. Then the bottom row is 7, 8, and 9. Who can tell me the 195 males? 195 males. Which box is that going to go ahead and belong to? Armando? Box 3. 195 males. That represents the total number of males at the school. Okay, what about the 126 females? 126 females, where is that going to go, Kai? Box 6, good. 126 females, so we have females total, 126. Okay, then it's broken down by the buses. The survey showed that 110 males and 84 females ride the bus. So 110 males that ride the bus is going to belong where? Let's go with Paris. Which box is going to have 110 male buses? Box 1. 110 is going to be located right here. It's 110 males that also ride the bus. What about the 84? 84 is going to belong where, Davinia? Box 4. Okay, it's females that are on the bus, so 84. Okay, and then the rest of the information we just fill in as we go. If we do 195 minus that 110, 195 minus 110, that's going to come out to 85. So there are 85 males that do not ride the bus. Then for the females that do not ride the bus, we're going to do 126 minus the 84. 126 minus the 84 is going to come out to 42 females that do not ride the bus. And then for the last rows, we would just add every one of these together. So we can do 110 plus the 84. That's going to come out to 194. For the no buses, that's 85 plus the 42. That's going to come out to 127 for total amount of kids that do not ride the bus. And then we can add 194 with 127, or we could do 195 plus 126. Either way, it comes out to 321 students total. Okay, any questions? All right, fantastic. If you log on to Google Classroom, you now have a quizzes assignment loaded up. You have one shot at it, one opportunity to take it. Please make sure that you do not exit out of it, because once you exit out, it will not let you back in unless you hit save. Try and get it done in the class period.